So I heard a rumor today that JWST is actually not going to launch until 2021.
I think that's more than a rumor, but yeah, I think that's the newest deadline now.
Yeah, that's pretty depressing. But if it ever launches, it's going to be absolutely amazing, and it's going to find all the like faintest galaxies. So like what I do, but way better.
Yeah, and people are going to use it to find planets around other stars that are fainter and smaller. But one thing they'll also do is look for dust around stars, both as the stars are forming and as they're dying, which is related to what I used to work on of dying stars, exploding stars, and supernovae.
And you can actually use like the death of a star to learn about what it was like during life, right?
Yeah, some interesting observations have been done by a few groups around the world to look at as the star's dying or as it's about to die, tell you something about its life.
That's really cool. And hey, do you know what one of the best ways is to solve the three body problem?
Have you fly across an ocean?
Yeah, you can actually collapse two of the bodies to make a two body problem, which is completely solvable. So I'm actually visiting Tucson, Arizona, and I have in the very same room Dr. Jen Andrews. So I first met Jen almost a year ago during the total solar eclipse when we helped a mutual friend do an event for the solar eclipse with the
So that's
public.
pretty impressive. And the host of that event was one of our other three body problem guests, I believe, right?
It was indeed, yes, Ashley Pagnotta.
So, Jen, who's a postdoc at Steward Observatory out at the University of Arizona, could you give us a quick summary of specifically massive stars and how they live and die? Because that's sort of your specialty and what we're going to talk about today.
Yeah. So when we talk about massive stars, we mean anything roughly 8 times the mass of the sun and larger, which for some astronomers, massive stars are things the size of the sun. But we like the 1% that shine the brightest and live the shortest. And because they're so massive, they run through their stellar fuel very, very quickly. And so you can, instead of living 10 billion years like our sun, they live 1 or 2 or 10 million years. So they're just very quick-lived but exciting events.
As your advisor likes to say, live fast, die young, I believe.
Exactly. And sometimes I think he lives by that same rule too. So
I totally agree with that, knowing him and hanging out with him at bars many, many times.
But to us, they're super interesting because it's a way to quickly take material that has been around and recycle it. So you form a star, it lives very quickly, it explodes, and then all of the heavier elements and everything that it's produced is back into the interstellar medium that can be swept up again and used to make more stars.
So these massive stars, they live fast, die young, they die pretty quickly. But before they die, your group and many others have been finding evidence that they go through these death gurgles, for hundreds or tens or even just a few years before the star really explodes and dies. It has sort of these eruptions.
Yeah, usually in the less massive stars, you have a very slow period where they just expand and expand and expand and expand. But with these massive stars, they reach a limit where all of a sudden they're producing way too much energy in their cores that the mass of the star itself can't really keep it in. So they can expand or have little explosions, like mini explosions, and because they want a nice equilibrium, right? So if you're too hot for your mass to handle, then you got to cool off a little bit and then allow yourself to cool back down. And as these transient surges have been going on, we've actually been finding more and more instances of this, and it's also making us keep a really close eye on stars, massive stars that we know have these burps, because eventually it's going to be the last bit of gas that they have, and we're going to hopefully witness a supernova explosion. Or, as an aside, if it just never seems to explode but it disappears, then we can maybe say, oh, well, there's a black hole. It just formed and disappeared. So it's always a good idea to keep an eye on these things. So there's way fewer of these guys in the universe than normal solar and less than solar mass stars, but I think they're the most interesting.
So I know that your former boss, Jeff, used to advise his undergraduate students to go out every night and check up on Betelgeuse to see if it had exploded yet.
Always keep an eye out for Betelgeuse. If it's up there in bright and red, we're good. If it disappeared or got really, really bright, give them a call.
So have you ever had a star that you're watching and you're like seeing it burp off bits of material and then you've actually seen it explode?
Yes, and Jeff may have a little more experience with that than I have. I didn't really dabble in the 2009 IP that much, but it's one of the exciting objects like this that happened and was under, and can still is under, a lot of controversy whether we did see a supernova explode. Yeah.
Yeah, that's one that people will still argue about. If we saw some of these death gurgles, people agree that they weren't the real explosion. Then we saw a pretty bright thing, and some people think that was the real explosion and the star blew up and it's gone. Some people think that was just a kind of bigger death gurgle, and we might see an even bigger explosion later. And as far as I know, people are still arguing about that to this day. And yeah, that went off in 2009, so almost a decade later, people are still arguing. So
infrared is obviously something that's very near and dear to my heart. And I'm also waiting anxiously for JWST. So what are you going to be able to do with JWST that you can't do currently?
Well, so currently we're the only way we would really be able to do anything from the ground is if it happened basically in our galaxy. So that even though we're overdue, that limits us a little bit. Or you can do it within the first month or two. And usually in that instance, the environment is just way too hot for the dust to be able to survive, unless it finds some pocket somewhere where it can form. So, but with JWST, we can go out to where the 400 or 500 Kelvin dust that is super bright when it's newly formed in these guys.
So we will definitely keep an eye on Betelgeuse. And it's really great to actually be here with you in person.
I know, I'm excited. Awesome. We're all in the same time zone.
That's right. First time.
There's zero body problems in this one. Well, thanks you guys so much for having me. This has been fun.
Yeah, this was great.
And now we can go find some lizards for Rachel.
Yeah. I'm so excited.
Lizards and cacti. Enjoy.